On the exam, do not put in 2.7 on the exam. It's in your calculator. It's kind of like pi. All you do is just second division and then it'll give you E. All right, let's continue how to solve some exponential equation. We see this again in 3.2, but let me introduce you some basics one first. Now, before I do that, let me ask you a question. You don't have to write this down. If I have 2 to the third equal 2 to the x, what can you deduct? X equal 3, right? It's just common sense. Common sense. Of course, there's a bunch of theories to prove this. There's, formal proof, but just by common sense, x equal 3, right? So that I can say that if I have a to the b, the base for b's, b for base, b to the n is equal b to the n, then it's implied that it's m equal n. Here, let it spade later. All right, so let's solve this. I have 2 to the 3x minus 8 equals 16. So first, I need to write both sides of the equation with the same base. So on the left hand side, it's okay. I will leave it like that. On the right hand side, how do I change the 16 into base 2? 2 to the what power gives you 16? 4, right? 2 to the 4. And now you can set them equal. 3x minus 8 equal 4. Solve for x. You guys know how to solve a linear equation. Add 8, so 3x equals 12. Divide both sides by 3, x equals 4. Okay. The last step you don't have to, but just because our first problem that you check to make sure you plug it back into the original problem. So I have 2 to the 3 times 4 minus 8 is indeed equal to 16. 3 times 4 is 12. 12 minus 8 is 4. 4 is 16. So yes. Check. So far so good. Yeah. Pretty simple. Of course, it's not. It's always simple like that. Okay, a little harder and harder as we go further down. All right, let's do this one. I have base 1/3 on the left. On the right. Naturally, what would you do? No, you cannot do that because the 1/3 being attached to the 2x minus 3. It's being held by that power. So we remember the step. What do I have to do? I just don't write a step for nothing. Same base, right? That's your cue. When you're solving exponential equation, meaning the variables of the power, you want to change to the same base. If they don't have the same base, we'll worry about that later. That's 3.2. So either I want to base 1/3 or maybe base 3. 27 is what to the what power? Yeah, 3 to the 3rd. So on the left hand side, I need to change that 1/3 into base 3. How do I do that?
Make something negative.
Yeah, you close. Yeah. So let me remind you, if I have a to the m, it's the same thing as what? 1 over a to the negative n. Right? Basically, you flip the side chains in the power. So if I have 1 over a to the n, or then it changes to what? A to the negative n over 1, but we don't write that, right? So maybe we pick the second one, right? I have 1/3. I need to be 3. So 3 to the what power? Very good. So 3 to the negative, and then I'm going to put a parenthesis, so that means the negative is for both numbers. So that's both of them are powers. And now you can set them equal. you have the same base? Maybe if you want, you can do like that, like cross it out. So negative 2x plus 3 equals 3. Subtract 3 both sides. Negative 2x equals 0. Divide both sides by negative 2. Maybe I'll write down. Let's cancel. So x equal what? What's 0 divided by negative 2? 0. I hope nobody say undefined. 0 on the top here. And then you can check. I'm not going to check. It's not required. You can check. This is not too bad. If you plug in 0 for x, you don't have to write down. That's gone, right? So 1/3 to the negative 3, the same thing as what? 3 to the negative 3, which is 3 cubed, right? Which is 27. So far, so good. It's just getting more elaborate, but that's the same procedure. You, as long as you make it to the same base, then you're good from there. You're good from there. Bless you. Okay, number 2. Let me change to something. Can you erase that square thing? In the morning, I keep it and I have a cubic function, which is it's not something I want to go into this class. You see that in pre-calc. Any suggestion? On the right hand side, I got base E, so I'm just gonna leave it like that. There's nothing I can do on the right hand side. On the left hand side, I have 2 bases. I think it's converted to one single base. Is there any rule allowed to do that? What does it mean, -1? No. I don't want to shoot. Forget about the powers. Just focus on the parenthesis, inside the parenthesis first. Yeah, that's a formula. What is it? Okay, close. What kind of formula? In general sense.
I got no idea.
But yeah, you close. You close. There's a formula. Exponential form. What is that? Test your own knowledge. A to the m divided by a to the n. What do I do? You divide, subtract, right? Quotient means go with subtraction. So m minus n. Right? If you have the base on the top and the base on the bottom is the same, you're allowed to subtract the powers. If it multiply, what do you do? Okay, all right. So let's do this. So e to the x divided by e's cube is the same thing as what? So outside is still 2x minus 3. On the inside is what? E to the what? X what? No? Minus 3. You just tell me to do that. It's minus 3, right? X is be your m, 3 is be your n. The n minus n is x minus 3. All right. Another rule. What do I do next? Let me rewrite the right hand side. What do I do next? There's a power rule. If I have a to the m and then parenthesis to the n, what do I do? Yeah, you multiply them. Let me tell you another rule. This is quotient, this is power, and then this is product rule. And then you add, right? Notice that they're different. Mess up all the time. They multiply for this one and add for that one. Love to do that. But yeah, the difference is here I have multiple bases, multiple same bases. Here's I only have one base and multiple powers. Multiple powers multiply, multiple bases. All right, so you remember your rule, right? You okay? So what do I do? What do I do next? The left hand side is what? That's your m. That's your n, right? N times n, right? So 2 to the x minus 3 times 2x minus 3 equal 2x. Now I can drop, they have the same base. I can drop. If you want, you can do like that. So let's FOIL it. I'll write it again. And now you can FOIL it. X times 2x is 2x squared. X times negative 3 is negative 3x. Negative 3 times 2x is negative 6x. And then negative 3 times negative 3 is positive 9. Subtract 2x both sides because I want to solve, meaning I want to set it equal to 0, right? So subtract 2x, subtract 2x. When you do that, make sure you write it under the same term. Right term. But you want to write it. I'm not going to subtract when you write it here or here. But you know, before I do that, I think I need to combine like term first. So 2x squared minus is a 9x plus 9 equals 2x. Okay, now I can subtract. So that's gone. 2x squared minus 11x plus 9 equals 0. Is it factorable? I don't think so. Is it factorable? 18 and 11. Product is 18 and then sum is negative 11. Find two numbers. 18, so 1, 18, no, 2, 9. Yeah. 2, 9, right? Maybe 2, 9. So do you guys remember factoring? So 2x squared minus 2x minus 9x plus 9. Where the 2x and 9x come from? That's what I said, 2, 9 earlier, right? You want to find two number, multiply to 18. Where 18 come from? AC method, 80 times 9 is 18. And then sum is the middle coefficient, which is negative 11. So two number multiply 18, add to negative 11. And what are you going to use that negative 2, negative 9 for? You split the middle term. And then because you have 4 term, you group factoring. What can I factor out for the first group? 2x, thank you. What's left? 1. Right, what can I factor out for the second group? Negative 9. Negative 9. So what's left? X. No. When you factor out the negative, it changes sign. So yeah. If you can check. If somebody says plus 1 here, if you multiply that, negative 9 times positive 1 is negative 9, which is not 1. But remember, when you factor out negative, it changes its sign. See, x become positive and 9 becomes negative. What else? What I can do more? I have those. Yeah, you have common factor again. So factor out x minus 1. And then what's left is 2x minus 9. Or 2x minus 9 times x minus 1 is the same thing. This implies what? This imply what? Well, if two numbers, if two factors multiply to be 0, then either one of them has to be 0, right? Or both. Right? At least one of them has to be 0. So this x minus 1 equals 0. Or and 2x minus 9 equals 0. x equal 1, x equal 9/2. On the exam, expect some quadratic equation. And I will make it in such a way that you can factor. If you don't know how to factor, you can use quadratic formula. I'm not going to restrict you how you want to solve it. I prefer factoring if I can. Do you have any questions? It's getting harder, isn't it? Tell you what, the next one is a little bit easier, nicer. I know it looks bad, but it's nicer. Any suggestions? Hint: you use the product rule, the third one in black, the third one down. That's the product rule. So apparently the side I'm working on is the left-hand side, right? But it's more complicated. This one is too lean. This is. You want to pick on the one, the busy one. Right, so how would I combine those two terms or two? Very good, right? The same base, all you do is add the powers. So 2 to the x plus 1 plus -3 equal 2 to the x minus 1. Just rewrite the right hand side. I can drop it now. So 2x minus 2 equal x minus 1. You know how to solve for x. Subtract x. I'll do like this. Both side. Yeah, that's gone. I'm gonna do it one shot. So and then I'm gonna because I want x on the left, so number gonna move to the right. So I'm gonna add 2. So that's gone. Let's see, 2x minus x is x. -1 positive 2 is 1. Or you can do in your head, just move things around. That step to step, that's fine.
Why don't you multiply the twos? Your base.
Are you talking about the first one?
Yeah.
What do
Why?
I?
Where did that 2 go? For the,
Oh, this, the base 2?
Yeah.
It's dropped. I have 2 to the something, that's the power, equal 2 to the something. So this implies what? The power is equal. But remember back here? Let me go back all the way to the beginning. Say I have 2q equal to 3x. That's imply x equal 3, right? Same thing here. Yeah, same thing. It's just more busier. It's more hairy. The power is more hairy. Oh, that's how you asking? What was? Yeah, this one. Yeah. Oh, where the 2 go? So I move this red 2 to the right, right? So I add 2. So 0. 1 positive 2 is 1. I need this to be gone. So I subtract x. Subtract x both sides. 0 to x minus x. I do this. You can do 2 steps, okay? I just thought you guys know how to solve the new equation, so I kind of do. Kind of combine the 2 steps together. But please, take your time. I'm allowed to make mistakes because I don't take the test. You guys, however, do. All right. All right. Any more questions for this one? Ooh, this is the bad one. This is the baddest boy, not all of them. All right, I'll give you half a minute. Just stare at it. Just tell me what you think. What will you do? Tell me what you're feeling. What would you do? Use all the knowledge you know.
What? Can I move half of that equation to the other side?
I would do it. I would do it.
So no.
Group them. How would I group them?
Would you make everything like this?
No, I wouldn't do that. Yes. Okay. She. It's not right, but it's a good thing. It's a good thinking. It's very good thinking. Anybody else? Is that what you say? Is that what you say? I saw a hand right. Yeah. Okay. So let me. That's what the first thing I do. That's what I did. But then I got stuck. I'll tell you why. 8 is the same thing as 2 to the what power? And then 2 to the x. But don't write this down. It's not right. And then because this is product rule, right? 2a to the n times a to the n is n plus n. So 2 to the what? 3 plus x or x plus 3. And then 2 to the 2x plus 2 to the 4. Then I'm stuck. I cannot drop it. Remember, my rule is what? If one term on the left equal the other term on the right, then I'm allowed to drop the base. But I have 3 terms here, right? It's something plus or minus something. It does not necessarily equal to single thing on the right. It isn't this. Yeah, this. I don't have that rule. You can check. Let's check. Don't write this down. Just scrap work. I say 2 to the square minus 2 to the first. Yeah, I don't know what to check now. 2 to the third. 2 to the third. Right? I cannot do that. Right? There's no rule. So it's what the left hand side equal 2 to the what? To the first. I'm sorry. What's hand side is what? 4 minus 2 is 2, right? Remember, it's subtracting. It's not like you add the power. You only add the power if increment or what? Multiplication. So I'm kind of stuck because I don't have any rules that let me go further down. Anything else? But it's a good thing. It's a good thinking. It's a good thing. That's the first thing I think. Change to the same base. Give yourself a bonus check for just for good thinking. Anything else? You exhausted your options.
You leave it blank.
I remember when I taught a class in the U of M, one of the students wrote, "She just took the wheel." I was like, yeah. I give him 1 point just to make me laugh. Don't do that on the exam. It worked for once, but might not work again. All right. Quadratic. Do you see it? Do you see quadratic here? Like Mimi, how is it quadratic? And nothing like it. Well, maybe I say it wrong. Quadratic in form. I think I did this in 662. Did anyone take 662? Raise your hand. 662. Maths 0662. The one before this. Yeah, right. You guys done this in 662? At least I taught my student. Maybe not this type, but it's kind of the same, right? So let me rewrite this. Let me transform this into something that maybe you can see it. 2 to the x, and then outside I put square. Is that okay? It's the same thing, yeah. Right? X times 2 is the same thing. 2 times x, right? Minus 8 times 2 to the x. If you want, you can do the first power. You don't have to write that down. Plus 16 equals 0. Do you see quadratic now? Square. First degree, the constant. X equals remember what's quadratic in form? Ax squared plus bx plus c, right? Let me write one more time. I'm gonna let u equal 2x, 2 to the x. So everywhere I see 2 to the x, I replace with u. So this become u squared minus 8u. Like I said, you don't have to write that little first power. Plus 16 equals 0. Is it quadratic? Yes. And it's better yet, you can factor it too. Can someone factor it for me? So the u and u. Two number multiply 16, add to -8. Yeah, 4, 4, -4, right? Oh, I let it's just easier for you to see. It's called substitution. You can leave it like that. Just here. I just let I call it graph. Graph equal u. Of course, we're gonna come back to it because it's not u that we solve the x, right? But just let the blob equal u, and then maybe it's just easier for you to see. So this imply what? So this imply u minus 4 equals 0, or u equal 4, and the same thing on the right hand side. So I'm gonna write. I'll do this for you for the. Another, and on the second factor is the same thing. So I'm just gonna write ones. Okay, so u equal 4. You're gonna use one. It's called double root. Now we're not solving for u. Yes.
I was just gonna ask that what made you substitute 2x with u?
Okay, good question. First of all, do you see this is quadratic? Yeah. Now, can you factor it just before you? Would it be a little bit harder for you to there? Yeah. So all I did is just I call it graph, and I let u equal 2x. You can take a different letter. What's your favorite letter? Say a. Let a equal 2x. Like any letter at all, just to make it cleaner. That's all. We'll come back to it. Back to it because we want to solve for x. We're not solving for u. Right. Now we're gonna substitute u back. So instead of u, we're gonna write what? Yeah. See, you come back to it. It's just not like you leave this hanging. Now we substitute back and then solve. We can solve for this x equal. X equal. Yeah. By the way, this is a double root. If you do the right side, it's x equal 2 again. Okay, so I'm gonna do that. It said it's quadratic. You should have a solution. Fundamental theorem of algebra. Is it the hard one? I thought it's a good one, but is there any more question before I move on to 3.2? Yes. Yes. You don't have to. That's why I put double roots. If you don't write twice, you don't have to say double roots. Yay, we done 3.1. 3.2 is log. Every student's nightmare. Have you guys done log? It was in high school. Yeah. 662 people definitely did log. What is logarithmic functions? Okay, so let's recall. Exponential function. Can someone remind me what are the two types of exponential function we know so far? Very good, thank you. Bonus check mark for you. Exponential growth looks like this. It's increasing from left to right. Go through 0, 1. In the growth case, b is what? B, it has to be greater than what? To be greater than, can be 1, right? 1 to the x is 1. Either 1, so greater than 1. Exponential decay looks like this. Still go through 0, 1. Decreasing from left to right. In this case, my b has to be between what number? Very good, right? 0 and 1. Not negative. B cannot be negative or 1. Remember? Either bigger than 1 or bigger than 1. We have two cases. Anyone remember what kind of test I'm using to determine whether my graph is a function? If you want to know what something is a function, what's the quickest way we do? Very good, right? I give you a function, any function, a funky looking one. All you do is plot point or use decimals, right? Once you have the graph, you use a horizontal line test. You draw any horizontal line at all. And somebody can draw it here, an arbitrary one. The number of the intersection is at most what? 1, right? Most 1. Then it means you have that it is a function. So yay, good news, a function. What about inverse? Well, you know what the inverse is. How do I check if the function is 1 to 1? What kind of test? There's horizontal, there's vertical, right? There's one. So vertical line test for testing 1-to-1 functions. So let me write that. So I'll just draw 1 here. And the gist is the same thing. You only allowed to cut the red graph or any graph at all there at most 1. At most 1. And in this case, it is. So yeah, it is a 1-to-1. Yes, it's a function. Yes, it is 1-to-1. What does 1-to-1 means? It means it has an inverse. What does inverse mean? It means the domain and range swap, right? So let me write this down and I'll explain it furthermore. So this means function has an inverse. So from now on, whenever you hear inverse, it means 1-to-1. Whenever you hear 1-to-1, it means it has an inverse. It's go both ways. Right? So what does inverse mean? You gotta remember long times ago, like I think it's many lectures ago. I asked you to graph a graph and then switch domain and range. So let me give you an example. Example with inverse function. If I give you f of x equal, say, x plus 1, just something simple. I want you to find f inverse. Do you remember this? How would you do it? Step 1 is you let f of x equal y. So let me talk about this original function here. So I'm going to let f of x equal y. So y equal x plus 1 here. Step 2, I'm going to swap x and y. So y becomes x becomes y. So x equal y plus 1. And then step 3, I'm going to solve for my new y. So solve for y. How do I solve for y? Subtract 1 both sides, right? So y equal x minus 1. And step 4, you substitute that y with f inverse. So that's the basic way of finding the f inverse. You work for any problem. As long as your variable is not on the problem. So I can give you a quadratic and you do the same. Right? Any problem, same procedure. Write f of x as y, swap x and y, solve for the new y, and then at the end, that's your f inverse. So same thing here. I want to find inverse of f of x equal b to the x. I'm going to apply the same procedure. I'm going to rewrite f of x equal y equal b to the x. What's my next step? Swap x and y, right? So it's going to be x equal b to the y. How do I solve for y? Leave a little space here. Now we stuck, right? Now we stuck. The reason we stuck because now y is all the way up top. Luckily, there's a function called log. It's allow you to untangle the exponential function. So if I add log both sides, maybe log base b. You know how you take square root both sides? The same thing. You add log base b. And there's another property, because log and b to the y is the inverse function, is cancel. It's cancel. So so this, the log babies and the b cancel. Why? Because of inverse. Now the y drop because this thing is disappear now. Now I have log baby of x, put the parenthesis here, equal y. And that is f inverse of x. Ooh, oh, that works. Just to explain. Again, I did explain things to you. I'm not gonna test you or any of these on the exam, but I need you to understand. That's all. So it turned out. That's my f of x, and then that's my inverse. All right. Now, informal definition, the thing that I need you to get out of the two slides, the first two slides. Okay. The two slide is that this. You've got to remember this for exam. Well, I'm not, log equal exponent. It would help you solve anything. It'll help you solve anything. Or at least like 80% of it. Which is makes sense. If you look back, log equal y. Well, y is the exponent. So log equal exponent. Remember that one. All right. I don't know why I do this. Yeah, I'll do that part first. I shouldn't put the thing there, but anyway, I'll do this first. Let me remind you the graph. Let's talk about the graph of log. I should have done it right here, like right here. I'll do it right here, because that's what I did in the morning. Remember what I said about inverse function? What the domain and range? Yes, swap, right? So the exponential function is y equal b to the x, looks like this. Again, I only talk about the grow case here. So I don't feel like doing both case. 0, 1. Okay, so I have 0, 1. Now my log graph, the graph of log is gonna go through what? Instead of 0, 1, go through what? 0, right? It's swap, remember it's swap. So it go to 1, 0, and it looks like this. And it's symmetric about the line y equal x. So maybe I'll just do it like that so you can see. And again, of course, if you have, say, 1, 2 here, it'll be 2, 1, right? So everything swaps, switching. Now, remember what the horizontal asymptote of the red graph is what? Y equal 0, right? Remember, everything is opposite for, so this one, instead of having horizontal asymptote, it has what? What has it? And then it'll be what? What's the equation? No, y. X equals 0, right? So y equals 0, and then the other one x equals 0. So everything is kind of opposite, right? not opposite, but switching thing around. Maybe I'll show you in the decimal out of the slide. Yesterday, went visit a. Oh, he's a Michigan Heart fan too. He sent me a link. Maybe I'll show you next time. This one. So let me mute that. Go back. There you go. That's the exponential graph in red, right? I want the log graph, so log base 2 now. There you go. It go through 1, 0, right? And it's symmetric around about the line y equal x. So they mirror image. The mirror image. By the way, if you watch this at home, you don't see what I show on the PC. I'm sorry. I tried to figure it out, but somehow my internet on the iPad is not the same internet here. So they won't let me share screen, AirPlay. All right. Convert exponential to log. It's fourth grade, but equal 16 is true. Yes, it's true. So this is exponential. I want to convert it to log. So this is equivalent to, I missed something. Maybe here. I missed something right here. Let me write one thing here. Y equal b to the x is equivalent to log baby of x equal y. Right? The twos are the same thing. That's a formal definition. However, you just want to know this. It doesn't do any, at least for the sake of your understanding. Okay, so let's do this. Yeah, I just copy those two things. I box it and put the equivalent notation in between. All right, just remember for me, x log equal exponent. That's all you need to know. You don't even have to remember that one. So let's convert from exponential to log. Remember, logs equal exponent. Leave a little space and then equal. What's the exponents here in the original problem? What's the exponents here? 2, right? So log equal. So out of nowhere, you know the log equal 2. 1 point for you, right? Now you fill in. I need the base and I need the input. Remember, I need B, and I need the little thing. Anything inside the parentheses is called input. What's the base here in the original problem? 4. Well, 16, know where to go. It's got to be there. And you want to check? You can use what I call a tornado arrow. 4 squared equal 16. You got to do the rest. See how you do. I'll walk around. Bless you.
Thank you.
I think there's a typo here. I think. It should be sorry. There's a typo. It should be 1,000 here. I'm so sorry. 3,000 there. Someone tell me what you got for the number 2. Base 10, logs base 10s of 1,000. Very good. Equal. Just makes sense. 10q equal 1,000. Third one. Base x of 3. Yeah, 1/2 is your exponent, so it's gonna be on the right hand side. Yeah. And then the last one. Base 10 again of -3, and then you can check. Usually I write log equal the power first, and then I just kind of fill things in, right? That's not how you do it on the exam. If I have something like that. Okay. This one even easier because I already showed you the tornado arrows. So basically, if I ask you to convert from exponential to log, you use this equation: logs equal exponents, right? If I ask you to convert log to exponents, you're gonna use a tornado arrow. So this one equal what? 4q equal 64, right? 4q equals 64. So this equivalent to 4q equals 64. It is true, right? 4q is 64. Number 2. You don't have to solve to tell me the exponential form. X to the 4 equal 81. Right? Can someone tell me what's x equal? Just curious. Very good. Yeah, x equal 3. But me not solving. Not yet. Typo here should be remove one of the zeros. Sorry. I have 100,000. It should be just 10,000. If I don't write the base for log, what is understood as? Very good. Base tens, right? So there's invisible tens there. It's kind of like square root. We don't write the index 2 in square root, but we know that's square root. So there's an invisible 10 here. 10 to the -4 equal. Yeah, 10 to the -4 equal 1/10. Or 10,000. Last one. Very good. Can someone tell me what's x equal? Just out of curiosity. 3. Oh, that's what it is. I know that I leave the space for the graph of log. That's what I did up here. So what was in that space? Let me see what I did. Let me see what I did now. Oh. I'll write things down here. There's exponential form. And if I want to convert to log, I do logs maybe for y, right? And if I want to convert back to exponential, I do the tornado arrow. From exponential to log, you're gonna use log equal exponent. Yeah, that's what I want to wrote. I know that this right here should be down here. Sorry, should be down there. I don't want to do it again. Yeah, if it's the same, if it's the same page, and yeah, but let's see if I can copy. See if I can do that. It will let me paste. Huh? That's what I did. I have a. No, it won't let me. And I cannot move it. I cannot duplicate and move it because it's different slide. It won't go through this that right here. All right. It's anyway. You see up there. Really right. Almost done. Do you guys want to take a let's finish this and then we call it a day. Okay, that's why I stop in the morning. So natural log. Oh, let's do the common log first. The common log is log base 10. Okay. So the common log is equivalent to log base 10. We don't write the base 10. Or the common log. You only write it. It just says log. On the calculator, you have log base 10 all by itself. I forgot what it was. What is it? Here. Right there. Right beneath x squared. Say log, and then you have 10 to the x. That's log base 10. Log base 10. The natural log. What is the natural exponential function? It had what base? What kind of base? We just did it. We just did it like in the beginning. If I ask natural exponential function, what base would you write? Base E. Base E. So the natural log is the one at base E. So log base E. Let me write this like this. Natural log. I know it's just bookkeeping. It's nothing here. I'm gonna test you, but you gotta know. Is equal to log base E. Is also equal to ln. N is for natural. You have this on your calculator as well. Right there, ln, right below log. Let me try something. I know where to go. Oh, right here. If you go to math, you go to math, and the first option, math, see fraction and all that. You can go all the way down, but I usually leave the upper arrow, so because all the way in the bottom. Go around. Log base. Now, a lot of time you're not gonna see base E or base 10, right? So sorry, the E there was there beginning, so you delete that. So log base, any base you want, say base 5, and then the input is say 7x. So any base you want. Okay, let's go to math and the very, very bottom option. All right, that's it for today. I'm gonna stop here because that's what I did in the morning.